All right, let's get started. Welcome back, everybody. As always, so today's lessons, there's not a huge amount here. I know that we've done a couple of kind of more complex things over the past couple days, and so probably the best use of our time is just to run through some questions. So queue them up in the chat, and I will go ahead and answer them. So today's lesson focuses on two sort of features of, these are patterns, really. Well, one of them is built into Java, but the other is sort of a convention. And these are sort of just adding to our toolbox of things that we can do with our objects. So we've learned how to create objects that combine state and behavior. We spent earlier this week talking about how to establish relationships between them. And then yesterday, today's Thursday, right? Yeah, yesterday we talked about sort of polymorphism a little bit and how to kind of, utilize those relationships and determine what type of object things are and stuff like that. And today we look at a couple of things that sort of emerge naturally from those conversations. One is being able to implement equality. And the other is a pattern for creating object copies. Java doesn't have a built-in way to create a copy of an object. If you need that, you can provide it yourself using something called a copy constructor. So the canonical sort of equality method that we looked at today is really something that is sort of boilerplate code. Most IDEs will generate it for you, but we're at the point now where we can understand it, right? So let's see here. I'm going to take over to my lesson here. So this pattern, right, where it's like I check for null, I check to make sure it's an instance of the class. I downcast it on line 10, which I can now do safely because I know it is a person. And then at that point, what I have is I have my own fields, and I have access to the fields on the other object, and I can do any mix of comparisons or any sort of work that I want to. The being able to establish equality is useful. It's more important in certain settings than others, right? You just have to think like, is my class really something that needs to be able to be equal to something else? There's certain applications, and we'll look at some stuff down the line, and certain applications where this is really important, and then there's other applications where it's less important. But this is the way, so the canonical approach, the canonical pattern for generating equals for a class. And then we talked about copy constructors. So what I'm going to do is I'm just going to kind of stop there. I'll hang out a little bit. If you guys have questions, stuff that you want to walk through, other types of questions from the last few days. I know that polymorphism and inheritance kind of coming right together is a lot to process, and so there may be still some misconceptions that I can clear up there. Otherwise, I am at your disposal for the remainder of the hour. So please do ask questions. Again, I know that this is kind of a conceptually treacherous part of the class, and so I do want to kind of stop down and slow down today and tomorrow and practice what we've learned, and use that as a chance to deepen our understanding before we go forward. So again, I am happy to answer questions, and would love to. So fire away. I will just sit tight for 5-10 minutes, and look forward to some great. You guys always have such good questions, so I'm looking forward to anything you guys might want to talk about today or see. There's some cool sort of things that came up with polymorphism the last couple of days, so please do ask about those, and I will do my best to answer. Overloading and overriding. Yeah, okay, good question. Two similar two similar ideas. Well, I'm not really sure the similar ideas, but similar words. So overloading, try to describe this in English first, then we can look at some examples. What we've talked about so far is method overloading. And that's the idea that I take a single name for a method, and I provide multiple different implementations for that method. And so I can show you an example of this, right? So for example, I could also create an equals method that takes, that returns, I don't know, a string, right? Well, actually, sorry, I can't create an equals method that returns a string. I have to change the signature, which does not include the return value. Well, let's create another equals method that takes an object and a Boolean. I don't know why I would do this, is equal. This is a silly example, right? And so I could just return is equal. And now I have, oh, I can't convert it to a string. I'll just return a Boolean as well, that's fine. So now I have two equals methods, right? And this is an example of method overloading. I have one equals method that takes an object as a parameter, and I have a second equals method that takes an object as a first parameter and a Boolean as the second parameter. And this is overloading. So it's like, you know, you can think of what I'm really overloading here is the name. When I started off, the name had one meaning. Now I'm adding meanings to it. I'm overloading that name. Java distinguishes between these by the parameters, right? So now if I add this parameter here, what's happening is I'm actually calling the second equals method that I defined right here, because Java sees that I'm passing both an object and a Boolean. And I could create as many of these methods as I want, right? I can create, you know, as long as they have different signatures, where the signature, as we pointed out before, is defined by the method name and the parameter types and position, right? So I could write another method, call it equals, and it could take a Boolean is equal and an object in the other order, and it would return not is equal. Now I've got three different methods that I can call, and now I'll call the third is equals method, and you'll see that it returns true because it's returning the first parameter negated. This is overloading. One name, multiple meanings. Overriding, yeah, so load you can think of as like, you know, imagine I'm putting stuff on a scale, I'm loading it up, and I put more and more and more on there, and it's getting heavier and heavier. I'm loading it. Overriding is actually replacing the implementation of a particular method that I inherited from my parent with my own. And so is equals is now overloaded in person because there are three different implementations of it depending on the parameter list. But only one of them overrides another method. And one way I can do this is I can use the override annotation. So if I put it on equals, it works. What happens if I put it on this equals? I'm going to get a compiler error. Remember, the use of this annotation is to indicate when a method that I'm implementing overrides a method from one of my superclasses. In this case, I only have one superclass, which is capital O object. When I add this override annotation, what it tells the compiler is this method should override a method in the superclass. If it doesn't, squawk, right? Which is what's happening here. And I'm getting an error. It says it does not override or implement a method from the supertype. And the second part of that we'll get to, right? In terms of why I might implement it. Same thing here. So if I put an override here, also not going to work because there is no dot equals method that I've inherited from a superclass that takes an object and a Boolean as parameters. And you know, we can look into this. So if I do Java object 14, and we look up, this is my superclass, right? I blow this up so it's nice and big. And you see the methods. The one that I'm overriding here is this one, Boolean equals. And there's no other overloads of this. Sometimes we refer to other methods with the same name and different parameters as overloads. There's no overloads of this in object. If there were, then I could override other overloads, right? So I'm using both of them in the same sentence, but there's only one. So there's only one override. When I override, so overloads on some level provide more methods with the same name. When I override a method, I still end up with the same number of methods. So and let's get rid of these guys because now they're just distraction. So when I have this equals method, and now I've got to change my call down here to work. So person has a dot equals method. If I remove this method, person still has a dot equals method. And so I'm added by overriding, I'm kind of replacing. I'm saying, I know how to do this better for my class, right? And that really is kind of what you're saying. If you think about like equality, the default dot equals method that is provided by capital O object is very simple. And we talk about exactly what it does. Essentially, it only returns true if you compare an object to the exactly same object. You may have a different definition of equality that you want to implement. By overriding the equals method, you can do that. And so it turns out, actually, there are a lot of things in Java that use this method, right? This is how you compare two objects. So if you implement your own equals method, there's a bunch of other pieces of Java code that you don't know about that use this to tell if two objects are the same. And once you change it, they'll use your implementation. So, as an example of this, there was a small problem with with the grading for today's homework problem, and the reason why the problem occurred is because you're implementing equals, and there are other things that our test runner does at various points that use equals, and some people were implementing equals incorrectly in a way that was throwing a class cast exception, and it was throwing a class cast exception in a place that we didn't expect to have one, and so it was actually crashing the grader. And that's because there's all sorts of other code out in Java that uses dot equals. And so if you change your implementation, that code is going to work a little bit differently. Anyway, so all to say that when you override a method, you replace the method that you inherited. And that's almost always done. I shouldn't say it's almost always done. It's always done to provide a better implementation. So same thing for toString, right? So toString is another method that we can overload. So let's look at how print works. By default, I get this not particularly helpful message because this is the default print method that I'm inherited. One thing that I think I pointed out, but I should probably point out again, when you call println on an object, what happens is that println calls toString. So this is equivalent. These two things are the same. If I just pass a bare object to println, what it's going to do is it's going to call toString on it. If I pass a string, it's going to call toString on it too, but a string to string, you get it. Anyway, but if that's what println's going to do, so I can just pass an object to println and it's going to call the toString method. If I have a better implementation of toString, I'm going to use the override annotation. I could provide it here, and I could say, return person. And then I'll do with name. Now I get this other implementation. I've overridden. So the class has the same number of methods. I've just provided a different implementation. So that's overriding, right? Overloading, providing multiple implementations of the same method, of a method with the same name with different parameters. Overriding, replacing a method inherited from a superclass, either my parent or some class up the tree. Yeah. Downcasting an instance of. Great questions. Yes, absolutely. Instance of. So the best way to think about instance of is to go back and look at these is-a relationships that we talked about. And I'll pull these up. So, when I extend another class, I enter into an is-a relationship with that class. So because pet here implicitly extends object, remember, if I don't explicitly extend object, it's still the same as this. If I don't explicitly extend a class, I extend object. So every pet is a pet. I think we can agree on that. But every pet is also an object. Now, when dog extends pet, if I start to extend other classes, I create even more is-a relationships. So now every dog is a dog. It's also a pet and an object through pet, right? Because pet extends object. Now to go down to mut, every mut is clearly a mut. Every class is itself. but because it extends dog, it also can be considered is a dog and is a pet and is a object. Instance of tests those relationships. So when you use instance of, what it does is it says, does this variable contain an instance of a class that has an is a relationship with the type on the right, right? And so what we can do down here if we want to is we can play with this. So we can say, well, let's create some, we need to create a variable here. So we'll say pet is equal to new pet. Well, actually, let's make this object, right? Because this will show you how this works. Object O is equal to new pet. So Java will do this upcast because pet is an object. So I've created a variable called O that can store any type of object. What I'm saving in it right now is a pet. So now let's look at this. Instance of pet. What's this going to return? Is this going to return true? Yeah, because what I have in here is a pet. Now let's change that to a string. Because remember, O can store any type of object. I can put anything in here I want. A string is not a pet. So what instance of does is it actually tests the current contents of the variable against the type. It says, does O currently contain something that can be considered in an is a relationship with this type? And this can change, right? So let's do this. Let's say O is equal to new pet, and then I'll say O equal to a string. And what's happening now? Okay. So now what you'll see is on line 14, instance of returns true, because at that point in the program, O contains an instance of pet. Once I get to line 15, I change O to refer to a string, to contain a string. Then on line 16, I test it again, and I see that instance of is false, because at that point in the program, O does not contain an instance of pet, or something that has an is a relationship with pet. So now let's keep testing here. So what if I make this a mutt? So is a mutt instance of pet? Yeah, it is. Is it an instance of dog? Yes, because it descends from dog. Is it an instance of pet? Yes, it extends from pet. Is it an instance of capital O object? Yes. So these the other way you can think of instance of is these are the classes that I could downcast this object or this variable to. So O currently contains an object, so I actually don't need to downcast it to object. But if I wanted to, I could downcast it to pet, and I could downcast it to dog, and I could downcast it all the way to mutt. Now let's have this be like a dog. So now we're in the middle. And so is every instance of a dog a mutt? No, because mutt is only one of the classes that extends dog, and there could be others. So this is false. So I can't downcast this variable to a mutt, because in this case, it's not a mutt. Can I downcast it to a pet? Yes, because every dog is a pet. And so dog has an is a relationship with pet. Currently, O contains a dog, etc. Can I downcast it to, yeah, I mean, these are the interesting ones. I mean, it's obviously a dog, so this is obviously true. So this is what instance of is for. It allows us to determine whether or not a particular variable that can contain multiple types. So object, this variable O, I can store pets in it, dogs in it, mutts in it, strings in it, any type of class I create in Java. Classes that you've never even heard of before. Classes that I haven't even created yet. Anything can be stored into O. And so if I want to actually, in a particular part of my program, tease this apart and figure out actually what's in there, instance of is how we do this. Yeah, exactly. So if you're calling print, you'd never need to use toString. Sometimes I use it just to be really explicit about what's happening, because otherwise people are like, oh, there's some magic. There's no magic. Like when you pass an object to print, it just calls toString on that to convert it to a string and then displays the output. But by making that really explicit, I think it's nice to just sort of remind you what's happening. Let's see, instance of, and then downcasted. Yeah. So object here, we just agreed, can contain an instance of any type of Java class. So instance of allows me to kind of figure out a little bit more about what it does contain. But what if I've upcast dog to an object, but what if I actually want to do something that I can only do with the dog? And so our kind of fun example is dog now has a woof method. What if I want to be able to call that? And actually, I'll come back to equality in a minute because this is a good segue. Right now, I can't call o.woof because the methods that I can call on a given variable are determined by the type of the variable, not by the type of the thing it happens to contain at that moment. So what the compiler is telling me is, hey, look, O can contain any type of Java object, and strings don't have a woof method. Pets don't even have a woof method. So there's all sorts of stuff that O could contain right now that doesn't have a woof method. If I want to be able to call woof, I need a variable of type dog. So that's the first thing I need, right? I need to somehow create a variable type dog, and I need to save the dog that is currently living in O into that new variable. And so what I can do is I can say dog D is equal to dog O. This is a downcast. Whenever I'm using an explicit cast, remember the int cast that we used to do with doubles and stuff like that? This is pretty similar. I'm forcing Java to do something that is unsafe. And so I can't if I do this like this, you're going to see that it's going to say I can't convert an object to a dog. Because there's all sorts of types of objects that you can't convert to a dog. Like if an object is a string, you can't convert it to a dog. It's impossible. You could create a method that takes a string and converts it to a dog, maybe by creating a new dog object and giving it the name that the string contains, but Java's not going to do that for you, right? So I have to explicitly tell Java to do this. Once I do that, now again, I said this is unsafe. Well, let's see why. So let's have this be a string, and now you see what happens. So here's what happened. I create, I have this variable called O, I saved a string into it, great. I printed off when it was an instance of dog, it printed false. That was a warning to me that I shouldn't do what I did next. Then on line 17, I told Java, take this thing that's a string and store it into a variable that can store instances of dogs. And at that point, Java throws its hands up and says, can't do it, right? And so the trick is, these two concepts, instance of and the downcasting, are almost always used together. Instance of allows me to determine that it's safe to downcast. And so what you typically see is something like this. If O instance of dog, then in here I create my variable, and now I can call d.woof. Now here you'll see that it doesn't crash. Why not? Because I never entered the if statement, right? So if I put a print statement in here, I never hit this. And that's because O doesn't contain a dog. So when I evaluate O instance of dog, it says, does string have an is-a relationship with dog? No. String's its own thing. String doesn't even know about dogs. I just created one. Dog's right here, right? So it's only if I have something that has an is-a relationship with dog, in which case I can do this. So anything that is a dog or extends dog. If I put a pet, same thing. Don't enter the if statement because not every pet is a dog. Does this help? Yeah, no. It's honestly the question. Control-Enter is the magic shortcut to run the code without clicking the button. I should document this stuff. Does it actually say this? No. Okay, it should. Yeah, no. Control-Enter. There's two kind of handy keyboard shortcuts. One is Escape, which closes the output window, and the other one is Control-Enter, which runs the code. So yeah, I should figure out a way to make that more apparent. Good. Yeah, great questions. Let me go back and see. Yeah, I think I answered the toString question. Is this so let's go actually look at back to equals, and we're going to look at this together again. So this is my equals example, and you'll see that I'm using instance of and I'm using downcasting as part of this, right? Because that the signature of equals is that it has to actually be able to accept any object, because there's pieces of Java code that basically are in a situation where they have two objects and they want to compare them. They don't know if they're the same type. They don't know what kind of is-a relationships they have. They have no idea. right? One of them might be a string, another might be a dog, they don't know. So that's why equals has, so you might ask, well, why doesn't equals have the type signature of person? And the reason is because there's cases in which I literally have two objects. Like I might have, you know, something like this where I say object first is equal to new person, object second, second is equal to new string, and I'm comparing the two. So I might be comparing two things that do, oh, I need to give it a name. I might be comparing two things that aren't even the same type. So the variable, the parameter that's passed to equals is of type object. And so the first thing I need to do in this equality method before I can start to deal with, oh, as if it's a person, is actually figure out, is it a person or not, right? Because I cannot do this downcast here unless it's a person. And so, you know, one of the things that people were doing on today's homework was forgetting this. And then, let's see here. Then you get this, it goes boom. Because I got down here and I told Java, take this string and make it into a person. And Java's like, no, won't do it. And so this is the pattern that we use. We always check, and you can do this in two statements or one statement, it doesn't matter, but we always check to make sure that O is an instance of a person before we actually do the downcast. Otherwise, the downcast can crash. And that's a runtime error too, which is pretty terrible. You know, that's something that's going to cause your app to crash in someone's face, which they don't tend to like. So yeah, we hit this class cast exception. So this goes back to this question about downcasting, right? And instance of, right? We see the two things right here. So until I know that object actually contains a person, I'm not going to do any more work. I'll put a print statement in here so you guys can see what's happening. Right, I don't hit this. Now, if I make this another person, now I get past that first conditional because O is not null and O is an instance of a person. So now I can do the downcast safely and do my checks. So that works out fine. What are the benefits of upcasting? Yeah. So this is a great question, and it's not something that's going to be obvious to us yet. But there are, when we get to the third half of the class, you know, starting a couple weeks, we have 2 more weeks on objects, and then we'll get into the data structures and algorithms part of the class, which is actually by far the most fun that we're going to have. We'll see why. So one of the reasons, for example, is you know, there are, and actually somebody asked a similar question last time, and I'll kind of make the same argument. So when I upcast, well actually let's talk about it. So, you know, imagine I have a I'm trying to think of what the right, no, I can't do max. Well, no, here, let's do this. We wrote search algorithms before, right? Let's write a really, really generic search algorithm here that will work on any type of Java object. So I'm just going to write a method. I'm going to call it public Boolean search. And then, now in the past, when we did search, we did like an int array value and then an int looking for something like this. And then we would say, you know, for int value in, I'll call this values because it's an array, int values, if value is equal to looking for, return true, otherwise return false. So this is my search pattern, right? Go through the array, and I'm not handling null and stuff like, okay, fine, I'll handle null. Values is equal to null, return false. Okay. So check for null, go through the array, compare things, return false. This is great. This is search. It's something called a linear search. Not particularly efficient, but that's fine for us. We're beginners. We're just learning. The problem with this, though, is that it only works for ints, right? What if I want to search for persons, right? Or pets or whatever. And so let's try to make this more general. And so the first thing I have to do is that I can't limit myself to an int value and an int parameter. That doesn't work. Instead, I need to make these objects. So now I can pass you an array of any Java object, and we can look through it for the thing we're looking for. So this check is still fine. If I have a null array, I can't do much. Down here, the things that are in my array are going to be objects. They're not going to be ints. And so I need to change my enhanced for loop up a little bit. So that's good. And then the other thing I need to do is I need to handle this. So this equality operator is not appropriate anymore because we're looking at objects rather than at ints. So I can't use the double equal equality operator. We kind of put that in our rear view. That's really only for primitive types. So how do we do this? Well, there you go. That's it. Now, there's a couple things wrong with this still. So actually what I need to do is I need to say if value is equal to null and looking for is equal to null, or value is equal to looking for. Because until I know, until I know that value is not null, I can't get to the right side of this, because if I call dot equals on null, it's going to blow up. This will also handle the case where they're both null, right? So if I'm looking for null in an array of objects, it's possible that one of those objects is null, and this will work. Okay. So, well, and I'm going to keep our person class, because we're going to keep this definition of equality for persons. So now, let's check this out. All right, so I'm going to create a couple of objects here. I'm going to create two strings. And I'll say new test here, and then I'll say string second is equal to new test there. So I've got two objects that are different. Now I'm going to say println search, and I'll create a new object, and I'll put first and second in there. And then I'll say I'm looking for first, just to make sure this works. Oh, yeah, these are strings, Geoff. Good. And oh, yeah. Bug off, check style. Boom. That works. What about if I look for a string that's not in the array? Let's look for another. This returns false. Okay, so now think about what we're actually doing here. When we call this method, we're upcasting, because this is a string. When I call the method, it's being automatically upcast to an object parameter. What's cool about this is that this search method is, the ring to rule all other rings or whatever. This is the search method to rule all other search methods. I can pass any array of Java objects here, and this will work. The only thing it requires, the only thing it depends on, is that the objects that I'm using have some reasonable definition of equality. This is why you override equals, because out there somewhere in some Java library is this function. In fact, I think it's part of the arrays, built-in Java arrays library. And it will use the equality method defined on your class. So let's look at how that works. Let's imagine that we don't define equality for a person class. And now I'm going to change these strings to be persons. So we'll say person first is equal to new person first. Person second is equal to new person second. One of the things that's awesome about this, I don't have to change any of the code in here because they're just objects. Now you'll see it returns true, but it returns true because I'm using the default object definition of equality, and I'm looking for an object that is actually literally in here. But let's say I create two people with the same name, right? Now, here what I'm saying is that I consider two people to be the same if they have the same name, but this returns false. Now, first of all, I just want to point out, I didn't change equals at all. I didn't change my search function at all. I didn't have to touch it. I could put this search function away somewhere and never touch it again. It works, and it will work for any type of Java object. Now, currently it's not working the way that I want it to, but that's my problem as the person who designed person, because I haven't told Java what it means for two people to be the same. And so now I'm going to uncomment my equals method here, and we're going to see that as soon as I define equality properly, well, bam, things work perfectly. Now again, this is under the assumption that two people are the same if they have the same name. That is not a good assumption when you're working with people, so don't make it, right? You need some other way. This is why we have social security numbers and university ID numbers. And India just did some big project, in the last 10 years. So they try to give everybody in the entire country some sort of identification number. Like, that's what this is for, right? Because, if you consider two people to be the same with the same name, actually that causes a lot of problems. Like, people get kicked out of, voter registration because they happen to have the same name as somebody who's like a felon or something like that. This is not an okay way to compare two real people together. But in the context of our program, we've decided this is fine for us. And you'll see that that definition of equality is now utilized by this search method. And so, and again, I know that you don't see upcasting maybe in the way that we've been looking at it when we use it to store a variable into another, to store something into a variable. But what's happening here is when I call the search method, I am doing an upcast. I'm upcasting, well, this is already an array of objects, but in order to put things into this array, I'm upcasting, right? This is an array of objects. What I'm putting in is a person. When I do that, Java says, can I upcast person to object? If the answer is yes, it'll allow me to put it in the array. If the answer is no, it won't. If you want me to convince you of that, if I change this to an array of strings, now I can't put a person in there. It's not like I can just make an array out of anything. Java uses these ISA relationships when I create arrays as well. So now the problem is I've got an array of strings and I'm trying to put something into it that doesn't have an ISA relationship with the string, and so that's why it blows up. So I'm upcasting when I put things into the array. I'm upcasting when I pass this parameter, which is a person, but it's being upcast to object. And you ask, what's the benefit? Well, the benefit is because this method is only using dot equals. Think about it. Like, I'm not making any other assumptions about these objects. I don't know that persons have a name. I don't know that dogs can woof. I don't know anything about any of the classes. All I'm using is one of the built-in methods from object, dot equals. And because of that, this method can be used on any object. So the benefit of upcasting is generality. Because we've written this program in a way that allows it to run on just objects, this search method, like I said, like this might be the code for search in arrays, the Java array utility class. And it works for anything. The only thing we have to do to make it work properly when we design a new class is make sure that we have a reasonable definition of equality that we've created for our class. If we do that, golden. And so this is, well, we're going to come back and talk about this concept more when we talk about interfaces. And that's kind of what's happening here, although it's a little bit unclear exactly how. But when we get to interfaces, we're going to go through some examples of places where you can essentially add a feature to your class, and then that feature can suddenly turn on all sorts of really cool code. So one of the examples that we'll get to when we talk about interfaces is being comparable. So what does it mean to be comparable? It means that I can put things in order. If you give me two instances of your class, I can tell you which goes first and which goes second. Maybe it's a tie, I can also tell you that too, but in general I can put things in order. Now, Java's default object does not include a notion of ordering. It includes a notion of equality, does not include a notion of ordering. The reason for this is that not every Java class can be ordered. And so in order to be ordered, you have to do some work, and I'm going to show you how to do that. But the reason is that as soon as your class can be ordered, there's a bunch of general purpose code that I can now use on it, like sorting, right? If you think about what does it mean, what do I need to be able to do to sort? At the end of the day, the only thing I have to be able to do to sort is compare two instances of a class together and figure out who goes first, who goes second. Once I have that capability, I just apply it over a large number of objects, and I can sort anything. Let's see here. Can we use this to make string equals case insensitive white space? Yeah. So if you wanted to do this with strings, so the question is, could I kind of change the definition of string? Here's the problem. String in Java can't be extended. So there's no way for you to create your own class. Now here's what we could do. Let's make our own string class and have some fun with it. So let's say, yeah, I get rid of this. Okay, I'm going to call this my string. Now I can't extend string. If I try to do this, what you're going to see is that I can't extend this class. And that's because when you create a class, and this is not something that we've told you yet, and we'll probably won't tell it to you in a great amount of detail, because this starts to get into sort of more advanced features of Java class design that aren't super useful. wait, I shouldn't say they're not useful. They're just not things that we need to dwell on right now. But the people who created Java string, who are kind of core Java developers, have marked this as final. And so there's no way to extend it. So I can't change its behavior in this way. What I can do, however, is this. So I could say private string my string. I can create a constructor, right? I could say public my string, and then I could pick a string set. I'll just call this string. It's a terrible variable name, but it is what it is. String is equal to set string. There's my constructor. My constructor takes a string. If I wanted to, there's several other string constructors. I could also duplicate them, but for now, I'm just going to allow you to create it by passing a string. And now what I'll do is I'll say public, so we want to modify equals, public equals object other. Now, here's where we can be a little bit more clever. And this will be kind of fun. So, I need to actually get the type signature right. Cool. So normally, when we compare to another class in equals, we only want to compare to instances of our class. But in this case, we can actually go a little farther than that. But let's do our class first, right? So I'm going to do the usual thing. If other is equal to null or not other instance of my string, return false. Otherwise, Geoff, you did it again. I always forget to use O for this variable. It's much nicer because then I use other down here. When after I do the cast, other, sorry, and then I'll say now let's just do normal equals first. So I'm going to do string dot equals O dot string, other dot string. And I could handle null here too. I could say, let's just put an assert in here just so I don't mess up and actually create this with a null string. All right. So now let's say my string first is equal to new my string, and I'll pass a my string second is equal to new my string test, and then I'll say system dot out dot println first dot equals second, and you're going to see that this is false, which is what I expected because I'm not doing anything different. Now what I could do is I could say two lower, is there a two lowercase? I think there is, dot equals others dot string dot two lowercase, and now it returns true, right? So now I've basically hacked the string the string class. Now again, you have to remember to always use my string instead of string, and you can't create it from a literal, right? So if I do this, what's going to happen is I'm going to get a complaint because Java doesn't know how to convert this to. So I'd always have to use the constructor, and so this is a limitation. But yeah, I mean, if you needed to have a string class that behaved slightly differently, you could do something like this as long as you were consistent about how you used it in your program. The one thing I was going to point out, and just let me do this briefly because actually I think this is kind of a fun exercise. So right now, I am not. So if I pass a string, right? Let's say I pass a string, it's going to be false, and the reason it's going to be false is I'm going to be in here. But if I wanted to, I could allow my class to be compared with strings, right? Because what I know is string. If I know it's a string, then I know how to do the comparison, right? So here's what I'm going to do. I'm going to change this to say if O is null, return false. Then what I'm going to do is I'm going to say return false, and I'm going to do two things. I'm going to take this up here, and I'm going to say if O instance of my string other. So I'm using that new instance of syntax that we saw where I can actually have it do the cast for me. And so now I can return, get rid of this guy, and now I'm doing this case-insensitive comparison. So far this just works the way that it worked before, but now I have an opportunity to handle other types of Java objects. So I could also say else if O instance of string, then what I'll do, take this, and I'm going to have to make a small change to it. I'll just do O dot two lowercase, sorry, no, this is mine, and then I need to do this here, other dot two lowercase. Boom. So now I can handle the case where you compare a string against an instance of my string. Here's the problem with this, though, because I don't want you to think, you might think, this is super clever, right? Here's the problem. What happens if I do this? It'll be false. Why? Because when I call dot equals, I'm not calling it on my string. I'm calling it on string. And string doesn't know anything about my string. So it doesn't care about my string. Doesn't have any way of figuring out what it should do here. Returns false. And so this is probably not a good idea. I just wanted to show you, because it's kind of fun and it gives us a chance to use the new instance of operator. But in general, you want your equality methods to be symmetric, right? Now there are cases where, let's say you have two classes that you created yourself. Then you maintain both equals methods. In that case, if there's a way to compare them to each other, you could implement that. But you have to do it in both places. In this case, I don't control the string class, and so I can't modify its equality method. And so now I'm stuck in this case where, again, I don't want to be, where essentially the equality method is not working in a symmetric way. So if I do first dot equals second and second dot equals first, I get two different answers, and this isn't really what I want. So the safer thing to do here is just to get rid of this, and that way, I can't compare with just bare strings, and I have to remember to use my strings throughout my program. But this is something that this is a safer approach. So I don't know why string is final. I don't know why you can't extend it. I suspect it has something to do with how literals are handled in Java, but I'm not sure. It doesn't. I don't know. It feels like this would be easier if I could just extend string and then override the equals method. But on some level, this is almost the same thing, right? When I extend another class, I still have to use that my new class whenever I need an instance of whatever that is in my program. And so it doesn't make things that much cleaner. The nicer thing about extension would be if you look at the string class documentation, it has a bunch of constructors. And by extending, I would inherit all those constructors. And so I wouldn't have to. I mean, this works fine for our example. We have one constructor that takes a string, but if you look at the string class, it has constructors that take an array of characters, and there's several other different things that it can do. So, so I'd have to duplicate all that here if I wanted it to work. If I wanted to be able to create strings exactly the way I can create strings normally. And of course, again, I'm never going to be able to use literals to initialize my string, which is another limitation. So, but yeah, this is what you could do. When you write the class, you're in control of equals. You decide what equality means. Good question. Well, again, I mean, something being final, I think this is an important point because Java is different than other programming languages in this respect. If you don't maintain a class, you cannot change its internals, right? So by extending a class and overriding equals, I don't change string equals. Someone over there who's still using string, they're still using the string equality method. In order to opt in to my new fancy equality method, you have to use my string. That would be the same if string was non-final. And so the final part really has to do with how convenient it is to extend something. I can still, like I'm doing right here, create kind of a wrapper class around string that works the way I want to. But importantly, that doesn't change how string works for anyone else. There are programming languages. JavaScript is one of them, where you, the programmer, can change how a certain thing works for everyone. Not the entire world, right? Not like somebody who's using code that, but if you take like a package and you import it into your project, code that somebody else wrote, that makes certain assumptions, you can cause those assumptions to fail. Now, this is typically not considered to be good. And the fact that the language allows this is typically considered to be bad. But most languages don't allow that sort of thing. So again, even by extending a class, I am not modifying that class. If someone else uses a string in their code and I extend string in my code, my extension has no impact on that. If they want to use my extension and use my string, then they're opting in to the changes that I made, and they have to understand what those mean for their program. But if they just use the built-in string, the only person that can modify that are the people that maintain Java, right? So and that's, on some level, if you think about it, that's what you want, right? I mean, you don't want, imagine if you were, if you're working at a company and, you had code and it was working pretty well and you're kind of proud of this new feature or this new whatever that you built that was part of the product. And then one day you show up and all your code is broken. And it's because some new developer they hired that you've never heard of that works in some other building, changed something about the entire, framework for the project that caused your code to suddenly break. That would be bad. And so most languages don't really allow that to happen. There are some, I actually, telling that story was reminding me years ago, I worked at Microsoft and I had an experience like that actually. It wasn't that someone changed something about the language, it was that somebody had changed some flags that were used to the compiler. So at the time I was working on, Windows in this Windows performance analysis group, and we would build some of the Windows source code, which was kind of fun. But someday someone decided that they were going to turn on a flag that checked for this particular thing. And that was something that I used to do in my code. And I actually think it was kind of a defensible programming pattern, but somebody decided they didn't like it. And so they flipped this flag and, it's like I went home Wednesday night and my code worked and I came back Thursday morning and everything was broken and I had to spend a few hours kind of going through and fixing all the places where I had used this. But yeah, no one had told me about it, but I was an intern, so, I was like, whatever. But yeah, no, I mean, stuff like that can happen, but it's usually done in a different way. The language level stuff usually gives people the heebie-jeebies, so most languages prevent that from happening. But yeah, good question. All right, we're out of time for today. Thanks for the great questions. I will be back. So tomorrow we're gonna do kind of just a sort of more of a tutorial type walkthrough the way we did last week. I'll probably show up and we'll have some more fun together, just kind of talking about stuff and going through it. But until then, I'll see you then.